video game development stream. You know what I'm thinking about? There was assertions that women could see more colors than men because women typically use more specific names for colors. But isn't that just a cultural expectation? Much to ponder. But we're not here to ponder about what is, you know, bioessentialism and what is just culture. We're here to make a video game. So I'm gonna open my blinds as well because it's dark in here. Have I shown off the intro to the game yet? I think I have. Oh, also my controller is broken. Eventually, Jackie will be sitting down and all sorts of cool stuff, but let's just use a note for now. And what I'll do, because Jackie's arms are stuck, she's going to be in a straitjacket in the final version of the game, but right now her arms are just kind of like A-posing. You know, good enough. How do I fix that weird gray thing there? I'll figure that out someday. But until that day, what am I doing? Oh yeah, I was gonna make I was gonna use today to make a wall placing tool. Because I got a lot of walls that need to be turned from these temporary art things into the more permanent art, which are down, all the way down over here. Ignore that giant rock that I haven't textured yet. Yeah, we need to turn these temp art walls into nice, fancy, these walls with the pillars and stuff. Because they'll maybe perform better eventually if I figure out automatic batching. Which will probably require switching to the whatever it is, the forward plus renderer, which might run slower, I don't know. I do know it has problems with shadows. Unlike this one, where the shadows are perfectly seamless and beautiful. But anyway. We don't even need to be in here right now. Because we're going to now go from the realm of video games into my favorite place, which is Blender Python scripting. We'll see how long I can go before I just have to give up and let ChatGPT do my learning for me. My wager is about 35 seconds before I hit just a complete roadblock. Because I've complained about it before, but Blender scripting is like incomprehensible to me. So what do I want to start with? I think I'm going to start from just this scene. And so what I envision... Let's go to my mind palace here. What exactly do I want? I want Python scripts. Update every time we edit, or like we change anything about the mesh. And so what it'll do, I wish I could like press the tab button to indent. Okay, I can. It just takes a bit. But I don't want to. Okay. So what I want it to do is, I'll show what I want the workflow to look like. I want it to be that I can draw walls, so like this would be the start and this would be the end. Like basically put posts at the ends, or put posts at each vertex. And then for each edge, what we're gonna do is, you know what, if I give up, I'm just gonna paste this whole comment into ChatGPT and figure out what it can do. I feel like I've been growing complacent, but Blender scripting is also the only place where I've used ChatGPT regularly, because it's just so hard to learn. I don't know how any human being has ever like learned how to script by Blender Python, because you have to have like different modes for every action, and some actions it's not the mode that you expect. Like to select triangles, you have to be in the object mode instead of the edit mode. It's a nightmare. But okay, for each edge, get the horizontal and vertical length. Or vertical distances. So we need some inputs. Or like attach to an object like a modifier. Has a list of wall pieces and a list and a post type. These are objects that will be script. We need the bounding box, or we need the size of the object. X, Y, Z. Actually, just X and Z. I think this might have to be a very complicated thing. Oh yeah, welcome to the stream, by the way. But yeah, I think if I can write it out, I think I can at least break down each piece into some sort of piece that I can understand. Also, I should make this a bit bigger. So yeah, for the vertical distance. What do I want for the vertical distance? What pieces are required? I guess we actually... So yeah, what pieces are required to stair step up the slope? Each piece could have like a... I'm gonna have to have a few things here. We need another visual aid. We need to bring in paint. Okay, so if we draw a line, basically what I want the algorithm to do is it'll be given some number of pieces. Let's actually do it like this. And what I want it to do is I want it to figure out which pieces would be optimal. For both the distance covered and the, I guess we can just make an assumption that each line will just have like one constant like slope, because that's typically how lines work, at least straight lines. And then it has to figure out what is the distance that we can go until, like, this is just about the limit that we could have here. So we could not use, for example, this piece. Because this piece, well, I guess we could, just barely. So it'd have to determine which pieces we can actually use here based on basically this x-axis and this z-axis. Because I'll just assume that's what I used for the walls, because that's how I built them. Welcome back. Right now I'm walking through my very elaborate... I mean, I say that sarcastically, but it actually is going to be very tricky, I think. But okay. I think I can just do this by making sure that we use only pieces where the z divided by x is greater than the z divided by x here. So determine the slope. Divided by vertical. No, it's rise over run. Classic. Yeah. Because there's a few very tricky pieces, I think. And then for each wall in our list, of the wall, x size divided by z size. If the wall has a lower slope, less than some constant times Wait, actually. So, create a... I know. Attach to an object like a modifier. Create some new object that we use for placing the wall pieces as a sibling. So I'll just write all of this out in human words. Clear the sibling object of any wall pieces. Put posts at each vertex, then for each edge, get the rise and run of the line, determine the slope, which is the rise divided by run. For each wall in our list, calculate the slope of the wall, or the max slope, and use some constant times size divided by that. So if the wall, or if the slope is too high for this wall, exclude it from the list of walls we place. So basically we have a filter here. So let's put that in here. Okay. And then we place the walls. This was not a smart idea, actually, to have this here. I can just use, like, my text editor that I like, instead of Blender. There we go. And then I can even do mark down. Look at that. Beautiful. Okay. Let's see. Yep, I've paid for Sublime. I've actually paid for it 3 times. I was tempted to make my own text editor, actually, because I didn't want to pay for it so many times, but I just couldn't find any editor that works as well as Sublime. Especially for the specific things that I like the ability to make custom syntax. Since that's what I did for, where's my dialogue? Probably in the dialogue folder. You know, because I just made this syntax highlighting, and it was really easy. Where for other, like, things, or other editors, you either have regexes that are way less powerful, or you have to do something called tree sitter, which is so complicated. I can't figure out how to use it. Yeah, what I'll do here. So yeah, now we place the walls. So when we place the walls, what we need to do is we need to get the constraints. This will be tricky, actually, because I think there's a few things that we can do. Basically, I'm trying to replicate my specific thing that I've done, which is for any post, we can have the walls either here or all the way intersecting with the post. And basically, I'm trying to figure out, is there a way that I can constraint solve for, like, this exact number? So, like, for this wall, for example, how many wall pieces do I need? And which ones? So basically, the reason that I want to do this is actually, I want the ability to be able to place it either here or, like, anywhere in here. Because the issue is, this might not be a clean multiple of the size of the wall. And so we can use the posts to fiddle with that distance by basically shifting around the wall's end inside of the post. So that way it's completely hidden from the player where they overlap or, like, don't intersect. So that way we can make it slightly longer or slightly shorter depending on the number of posts we have. Yeah, I'm gonna make the walls fixed size meshes, because that way it'll be more easy for, like, collision and file size and all that stuff. And that's the big complexity with this thing. Though I guess what I could do is just make it not exactly match the size and just pick whichever, like, wall pieces are the most suitable. In fact, that would probably be a good first step. Let's say simple version. Just place wall pieces, or place the smallest number of wall pieces. So this would probably be, get the vertical list, or get the, yeah, because there's 2 variables, basically. One consideration is filtering out the pieces that don't rise fast enough for the wall, or that have, like, a slope that would not be compatible with it. Like, this one, for example, is already a little bit incompatible with this wall. But I think what I can do is, or I think this part isn't too bad, and the simple version of this problem isn't too bad. Basically, we just get the horizontal distance of the line for each piece, sorted from longest to shortest. Place as many pieces as we can without going over the line. Or without end to end. Center the piece vertically. Its origin intersects rotate the piece such that its x-axis aligns with the line. If there's any, let's see, if the remaining distance without going over the line, unless unless we exceed the horizontal distance by less than half the distance of the smallest wall piece. And then optionally, place a wall piece, or place a pillar at the end. Also, I should put in here, wall, this can end to end is the distance barely touch minus some margin. Now I actually had to I added custom key bindings so that I hold Alt and comma and period for the nice quotes. And now I've gotten so used to it that I don't even use the neutral quotes. Yeah, it messes me up every time that I use something other than Sublime. So eventually I need to just get like there's a tool called like WinCompose that lets you type special characters like that throughout the whole operating system. Yeah, I thought it was neat. I made it mainly because, especially for the writing in the game, I wanted to use the nice fancy quotes rather than the neutral quotes. But okay, I want to see, can we attach to an object like a modifier? Or can we make custom modifiers? Scripting a new object modifier. Oh, yeah. Operators are... The problem is, the only scripts that I ever see use the operators, but here it's still explaining how, like, the operators are really error prone and not very useful, which I know, but I don't know how to see any of the other APIs. Add and apply a Boolean, which we don't really need that. So it's a Blender custom modifier. Because I think the big question is going to be, I don't know how to, let's see. Oh, no. No, that's going to be way too complicated. I'm not making a Blender modifier in C++. The modifier part of... Okay. Python is used to write add-ons, but there are some that can rebuild, change some types of geometry later. Yeah. It seems like to write a custom modifier, it's just using C++, so that's not really gonna be an option. I'll have to figure out some other way of, like, basically I want to configure this object in the editor where I can just do, like, in one of these scripts somewhere, maybe in, like, custom properties, I would add, like, you know, generate mesh true or something like that. Or, like, generate walls. And then it'd just be, like, a Boolean. How many properties do we have, actually? Python. Edit a Python value directly for unsupported property types. What is a data block? Ooh. And then we can do object, and we could do object. No, what would this be? This would be like pillar. Okay, so we can kind of do stuff here. So I think the main question then would be, how do I add custom properties to a custom object? And then we could do, like, let's link all of our cool objects. They're going to be in here. Can I link multiple things at once? I really hope I can. No, I can't. Okay. Thank you, Godot. So this is what? Wall 9 simple post? Yeah, thank you, Blender. I misspoke. It's a force of habit. Oh. Oh, it's wall 7. Silly me. Okay, so this is stone. Wall 8. Simple short. I think what I can do... Ooh. The main issue is that I really would like to get the actual mesh here, but I don't think we can because we don't get the, like, size of the object. Stone, wall 9, simple wall. Wall 10, simple medium. So this will be like reference. And this will be like my wall. Then we can hide this. And let's call this, so this is going to be an assets, I think, test, wall test. So, like, Blender run script whenever mesh changes. Not all changes are sent through a message bus. Depths graph update handler. I think I might not be able to do the live preview, which is going to be a shame, because I'd really like that. But what I can do at least is not bother with that. And then the real question is, how do I get the objects, like, can I view the bounding box of this object from within here? Yeah, because I'll have to figure out something much more sophisticated. You know what? We need to get Bing chilling in here. I wish it didn't like put my like entire full first and last name and social security number on here every time I showed this. Actually, I can just block this. There we go. I just used ad blocker to block my name. In Blender Python, how do I get the bounding box? Oh wait, actually, what I should do first, Blender Python, size of objects. I mean, admittedly, I'm not really doing that much more, like, thinking, because right now all I'm doing is just going to Stack Overflow and asking them, because the documentation is like completely unusable. Empty display size, use instance faces scale. So like, yeah, unfortunately, there's a lot of documentation here, but like, none of it is useful, because none of it tells you like what context you're allowed to call this in, or like how it's used, or what it returns, or anything like that. I mean, I guess it does tell you like what it returns, but it's very difficult to actually figure out how to use anything in this scripting or in this API. Yeah, let's see this. Yeah, you know what? Let's go to the console. Oh, wait, actually, I don't want this here. Well, maybe I do. Is there like... Oh, there's a thing here. Data? Objects? bpi.context.object. Interesting. So how do we like view this? Is there like values? Okay. So we have my wall, we have the stone walls, we have low res. Okay. So we are actually getting some things in here. We could do objects.collections. Okay. So if I go to my wall and I add a custom property, actually, can I add a list of properties? I bet you I can by just changing this. Oh, we don't need that. We need Python as our type here. Oh, here, actually. So value none. No, actually this one can be a data block. Because yeah, what we actually need is wall pieces. And this one will be a Python block. Because this one's going to be a list. So what I think I can do is I can do bpi.data.objects my wall dot wall piece dot custom properties. Actually, can we do... Okay, we can do this, tab. So I would like to see if we can get the custom properties of this. Okay, this is actually quite useful. And I'll hope that I can actually like use some of these. So what we could do is we could do bpi.context.activeObject dot see this. Context has no attribute oh, I misspelled it. Dot, what do we get from here? Blender Python custom properties. Okay, so it's just the index. So we could do like a pillar. I thought we could. Huh. I was hoping that these would like... It used to like show you a name here. Oh, properties. Interesting. Thank you, Blender. This was supposed to be Python. There we go. It's still not working. Can we get an array in here? Yeah, was there actually an array? There's float and integer and boolean arrays. But yeah, we need an array of data blocks. Because what I want these wall pieces to be is the array of these guys. But okay. Hmm. Do we have, like, a property list here? Is property set? Is editable? ID properties, ID data? Hmm. That doesn't help me much. Values? RNA struct ID props. Vertex groups. Hmm. Some of these actually print values. Some of these only print, like, other things that I don't understand. And you know what? Let's just bring this... Oh. Actually, I have a good idea. Bring this whole thing here. And then we just have this over here. And then, oh, it killed my whole thing. And also, the console is now here. Thank you, Blender. Hang on. I think we need to swap this with this. Or, like, put it somewhere else, like here. And then turn this one into a console. So that way one of these will not have the keyboard taking up 95% of the... Yeah, okay, there we go. Now I've killed my, like, little keyboard telling thing. C.active. Object. But yeah, I could have sworn it's... I mean, it says... So, .objects cube test prop. You can access it with that. If you don't know the property names, you can get it by keys. Which I think is going to give us everything. No, it's not going to give us anything. Okay, that's pretty cool. I like that. Can I do, like, obj equals? Okay, that makes sense. Then what is... What am I looking at? Then what is obj? So it's an object. But it's like... Hmm. Oh, I just realized there's a superpower in Python, which is the like, comment strings. But okay. So is there some difference? If I do bpy.data objects my wall dot keys or objects. Okay, thankfully that returns the same thing. I just don't understand what it is. Hmm. Hmm. So, I don't understand what keys is giving me. Okay, what is an ID property group view keys? Like, this is gonna be, I think this is gonna be a lot of stuff. So ID property access, this isn't gonna be useful to us, I don't think. So if we just go to active objects, bpy.types.object. So what does the object have? It has all this stuff. So we've seen all of this from the thing. So like properties. Inherited properties, properties clear, properties ensure UI. Keys. Shape key clear, bpy.struct.keys. I don't think these are the same thing. Okay. So this doesn't give us anything at all. I don't know where keys comes from. I don't know where it goes. I guess it's bpy.struct.keys, or bpy.struct.keys. Returns the keys of this object's custom properties, matches Python's dictionary function of the same name. And it returns one of these. This is incomprehensible. So can we do like a .to list then? No. So then why is it in here? What is this? How do I iterate over this? Can I print this? Like for k in print k. So we have one property called cycles, even though I've created two custom properties called pillar and wall pieces. Unless I'm going crazy and this is like not the right thing. Oh, interesting. I didn't realize you could change the mesh here. That's nice. So could we do like dot items? Oh wait, print K, whoops. Okay, so this gets us the same thing. Owner my wall name equals cycles, address equals 0 blah. This isn't even a property of the thing. Okay. So did they change how these work, or am I just an idiot? Can I set a custom object? So if I just did like, you know, c.activeObject gamer equals true with a capital T. Okay, so did that do anything here? Okay, so it's here. So what if we save and then we revert? And then we see what's here. And we see c dot active object dot gamer. Okay, no thing there. We can do items. No, we can't do items. I wish, against all hope, that, like, it would tell me what methods this has. So there's, like, no information whatsoever on how this works. Like, I'm pressing tab and there's nothing there. Okay, so let's print it again. Advanced. Oh, thank you. Okay, so we do have gamer in here. It has been lost to the ether. Oh, it's because it's the... Is it because it's the plane? It's the object data. Okay. Data? No, so it's like, so now it's actually D dot... I think what this is meshes. Plane. Dot keys. And then, as we have to do for C in this, print C. Very convenient. Thank you, Blender, for not creating a, like, printable representation of the list of properties on an object. Thank you for that. Okay. So the object does not have properties. You can't add custom properties to the object, I don't think. Unless it's somewhere that I'm not... Oh, it's here. Okay, I see. So we can add it here on this thing, not on this thing. If we want it to be, like, easy to edit. Because now we could do this here, where we have this changed to, like, pillar. And this would be our data block. And then we'd have, like, wall pieces. Let's have it be an empty list. Okay. So now we can go through activeItems.items. And then, like... Can we print, like, a list of things? Is there, like, a map function in... I guess it could just be for C in this print C. Okay. Inexplicably, it has a property called cycles. I don't know where that's from. This is a bpi id prop. Owner equals this. Name equals cycles. Address equals this. Well, we don't need to worry about that. And what we can do is we can have a boolean here, and this will be called, like, intermediate, or, like, place every pillar. Okay. So now what we can do is d.activeObject. Or, like, pillars here. Equals, this is gonna be tough. No, it's gonna be d.objects dot stone wall 7 simple post d.objects stone wall 8 simple short. Wall 9 simple long. Oh, hang on. Wall 10, simple, medium. Okay. So now we can do c dot active wall pieces dot this dot okay. We can see we got all of our objects here. And so that, at the very least, I can at the very least create this. So what I'm going to do is I'm going to create just a function that allows me to do this automatically. It's like def wall init. Actually, can we do an array of strings? That'd be really useful, actually. I think we could do that. Ooh. I mean, we could do like a comma separated list of strings. Let's say semicolon separated list of strings. And this will be like wall pieces or something like that. And so that way, what we would do is var, or like wall, no, let's say mesh equals bpy.context.active object if, I think we can do like if gamer in c.active object print yes. If not in, that's useful. Okay. So if wall pieces not in mesh, can we print, where do we print errors? So there's report. Use an operator's report method. I don't like that very much. Pop-up menu. So we can at least do a pop-up menu. So icon equals error, title equals error, pop-up menu. This mesh doesn't have whatever it does. Mesh. And this one will be, doesn't have the pillar property. So this should go into assets, environment. Let's call it make wall, or like wall builder. And what I'll do is like def, or like wall init for now. I hope, how do I figure out, I'm trying to figure out, is there a way that I can compile a script without running it? I know. mesh. So if wall piece list not in mesh wall init mesh. So this way it's like idempotent. It'll only run once. And eventually what we'll do is we'll have this actually do a thing. But for now it's just going to do equals probably like mesh.wall pieces.split semicolon. Actually, we don't need the whole console here. Alright, so assets, environment, wall builder. So we can just do this. Name bpy is not defined. Oh, we have to import bpy. That makes sense. Oh, now I have to, now it's best if I use it here and edit it here. Nope, not quite. Wall init object has no attribute wall pieces. Oh. Okay. So now what it can do, so you can run this. Why is this named differently? Hang on. Go to this one, remove this one. Go to this one. And can we, like, save this somewhere? Oh yeah, it's text save. There we go. List object has no attribute split. Oh yeah, because this one, I didn't do the thing. Yeah, we need to, like, remove all of these. And then we can run this. String object is not callable. Okay, that makes sense. Wait, where was that error? Do we have, like, a log? Info? Okay, there it is. String object is not callable. This is in line 270 of bpy types with no stack trace. Love to see it. Drawfunc pop-up bpy.context. Oh, I see. Okay. Oh. We need a function that returns a thing. So we need to make a distinct function here for, like, this. And thank you, Blender, for not letting me scroll to the end of the start of the thing with no horizontal scroll bar. I like that I have to use this because otherwise it gets out of sync and I have to manually reload it. But okay, missing... And if I remember right, Blender's, or Python's lambda functions are, like, crippled. Yeah, because I think, actually, we might as well go all the way like this, so that way we at least have, like, a bad text editor, instead of, like, a bad and tiny text editor. Yeah, lambdas suck in Python, because you can't actually, like, do a thing. Like, you can only do this, and what we need is a function that sets an object. And that's going to be annoying. Are there, like, nested functions in Python? Okay, good. So what we can do is we can have define missing, like, prop. I like that they defined it this way so that I can't, like, make this universal. Like, I can't just have a function that returns a function. I have to do this. The mesh doesn't have the pillar property. I guess this is fine. So missing pillar. So I have to copy this. And then we do missing wall. There we go. Oh, and then missing pillar here. Okay. Then wall pieces not in mesh. Inconsistent use of... Oh, thank you, Blender. I love that it's... Inconsistent use of tabs and spaces. Jesus Christ. Oh, thank you, Blender. Is it... It's like everything is working against me. Every single person is my enemy here. And then we go back into here. Reload. Okay, so it's not that bad. Yeah. Admittedly, here it's more like the indentation is really screwy. Because, like, what I'd want by default is basically for, like, the indentation to be right in the text editor. Oh, interesting. Nice. Okay. Is this gonna... The mesh doesn't have the wall pieces property. Well, as long as I fix the typo. Now it actually says the correct thing. So basically, this mesh doesn't have the wall pieces property. Easy. Because what we need is we need the wall pieces property. It'll be absolutely miserable to edit, but basically what it's going to be is, let's see. Stone, wall 7, simple, post, stone, wall 8, simple, short, stone 9. Oh wait, no, we don't need the post. Silly me. Stone. Yeah. Because otherwise I have to do it in Python only, and that's going to get more difficult. Because there's no way to just have a list of properties. I mean, I guess I could just have, like, wall 0 through X. Honestly, actually, now that I say that, that'd be easier. Basically just have 3 properties. Make each of these a data block. And what I have instead is, like, wall 1. And we're going to start from indexing 1. Wall 2. Wall 3. Now we're gaming. So yeah, instead of having an array, I just have to have a hard-coded, like, I mean, I guess it's a list of properties, so I might as well do it this way. Yeah, that'll be fine. Basically, I'll just do, for W in, let's see here. So if pillar, not in mesh, we'll do that. And then let's do meshes equals this. Actually, you know what I'm going to do? Let's bring this into, or let's just go into here, because now that I know how to, like, I can edit things in here, and then it just, like, works by default by doing this. Well, hi, I'm working on some Blender scripting, because my dream is to have this line automatically place pieces of this wall. So basically, like, you know, something like that, basically. Kind of. But, like, you know, done well. And I'm hoping that I can do it in less time than it would take to hand place, like, the 1,000+ walls that I need. But I don't know if that's actually going to be the case. Wall pieces. So let's actually have this be this. So right now I'm just getting the list of wall pieces, which is going to be like 4K in... Let's say for W in mesh dot ease. No, values. If W... How do I figure out if something is a mesh? Or I guess, let's say, let's go keys first. So like if K dot begins with wall, then I think it starts with, actually. What we're gonna do is yeah, my brain has expanded 3 sizes today, and I haven't even, like, done any of the logic to actually do it yet. I've just figured out how to actually view properties on an object. But if it starts with a wall, we can do wall pieces equals mesh wall. And we'll see if that works. Actually, I should be able to figure out Blender Python data block. So can they have, like, types? No, we need collections, actually. Or we need the base scene, or the base type of this. I wish I was, like, in the Python library. Yeah, I think Blender has that. Because Godot or GDScript is very similar. String starts with... Oh no, Python string. What? So internet search is broken. It's literally, like, not useful anymore. Okay, where's the Python, like, actual reference? Because I'm seeing starts underscore with and starts with without the underscore. Is this, like... Begins. Prefix. I know there's a string thing here. Okay. What is happening here? Mm-hmm. Whatever. Yeah, search is dead. You can't find basic information anymore. Like if there's a function in Python called starts_with, or if it's called starts_with. But okay, what I'm going to do for now... No, what I wanted to do was figure out if I could get the correct type. Like if... whatever. We'll just say this is this. And then also, we don't have this anymore. Okay, so if I run this now. Wall pieces equals nothing. Unindent does not match outer indentation level. Okay. Jesus fucking Christ, Sublime text. Tool that I use to edit text. Make it consistent. How did I even get... I think it's Blender. I should just not edit in here. Hang on. Move this to like this corner. And then get this out of here. So that way we can just do like... Just run this thing here. There we go. Starts with. Okay, so it is starts with without the underscore. Thank you, Python. Key wall not found. Oh, because it's... Oh, because it actually was... Key K. So I think it sometimes uses space because Blender automatically inserts spaces, I think. So if I did like... Let's do like this. And then we come into here. Alt-S, actually. Yeah, that's the issue. Blender puts in spaces by default, and Sublime puts in tabs. Yeah, because actually Sublime just automatically figures out what you're using and tries to indent the same way. Oh, I messed it up again. I forgot to do this. Did it work? So what do we have here? We have wall pieces. And it should be... Okay, so that should be good. So that means that now we can do this. And the way that I can clear this is by doing that and then running it again. And then it's here. And then what we need is else, like a wall place mesh. And this is going to be where it gets more difficult, I think. Oh wait, hang on. I should not do it in here. So yeah, how do we get the data from an object? Actually, I just realized we still have the console here. So I think what we can do is so c.activeObject dot should be somewhere in here, maybe like mesh or data or something like that. Data dot, what do we have in here? Vertex colors, vertex normals, vertices. Okay. So for v in mesh dot active, or no, mesh dot data dot vertices. That's print v. You know, now that I know that I can just do this, this is much easier. So can we get like v dot position? Let's see mesh vertex here. Co. What's co? Undeformed? Oh, it's coordinate. Okay, that's, you know, easy to remember. Thank you, Blender. So we're gonna do... Let's go back to here. Co. Okay, so I think this is our world position coordinate, so that's good. You know, we're also going to do, like, if sister not in mesh. Can we add an object at the same position How do I do that for the other thing? So, like, creating the other Python script, make low res. Split and rename. So we do an object.duplicate. Let's do, like, Blender add new item. Or create new object. Oh, whoops. Blender Python. Okay, we can do bpy.data.objects.new. New, so it would be name and whatever it was before. So new name plus mesh. What is me? Oh, I see, mesh. Okay. So I don't think we need that. We can just do this. And we're gonna do mesh.name plus sister. Parent equals mesh.parent. And actually this should be called object instead. And you know what? obj.name. Let's see if that works. For k if oh, I see. There we go. Okay, so now it does a thing. I don't think it did anything yet. Oh, because we have wall pieces still, so it didn't init. Okay. Object data not specified. What if we did none here? And then we run it. And then we should have created an object here Unless, oh, I see. Okay, so it creates a thing here, but then it doesn't do anything here. So where's the, let's view the Blender file. Ah. We need to put these in the same collection, I think. That's gonna be annoying. Actually, can we just do like sister.collection equals obj.collection, and then we have like obj sister equals sister. Object dot collection. How do we do anything with the, let's do Blender Python move to collection. Scene.collection.children.get that. Okay. So we can't just get the collection that we're in, or can we? If I did active collection. Oh, we can do this. Okay, that's good. I'm just going to do c.collection. Like bpy.context.collection.link sister. So that should put the sister in the right place. And then I'm going to delete that. And then we're going to have all that stuff as it is. Run this. Okay, so now we have sister here. And it is empty. And if we go to scenes, no, if we go to collection somewhere, view layer. Collection has no attribute link. Oh, I thought it did. Items, pop preview, so move object to collection. Oh, is there, oh wait, no. Okay, I see. Wait, so even with the object and the collection, we require a loop through the thing. No, that doesn't make any sense. No, okay, I see. It's collection.objects. There we go. And now it exists. And now it's in here. And look at that. Now we have it, ladies and gentlemen. And what I'll do is I'll have it have the same transform. So we can do like sister.transform equals obj.transform. I think that'll work. Yeah, it's not exactly, it's not making it easy for me. Do we have like a position? What do we have here to like set the like location? Okay, it's just location. Rotation. Oh, whoops. I keep scale. And then also sister. I'll assume this is correct. Until it's not correct. Actually, don't we need some sort of like inverse transform from this thing? Matrix parent inverse matrix. Oh wait, we could do matrix world equals matrix world actually. And this should make it so that once we add the object here... Oh wait, wrong thing. Actually, what I'd like even more is to add a constraint to the object so that it always copies the transforms of the wall. In fact, then we don't even need any of this. So let's do like, yeah, you know what? C.ActiveObject dot constraints dot add. So how do we insert new? I think it's going to be copy transforms C equals C. Okay. So then I'm beginning to see the logic here. So con dot C dot, what do we have here? This is actually really useful. I like this console. I have finally learned how to learn Blender scripting. I haven't learned the Blender scripting yet, but I've learned how to learn it. Kind of. But okay, so I think what we want... Well, target makes sense. No. Wait, I don't get it. Target object, probably. Okay, con.target equals obj. Okay, and now we have sister here. And then what I need to do is I need to figure out what objects this has. So we could do like c.activeObject.children. Okay. So can we delete the hierarchy? Actually, what I'm going to do instead of this is if sister in obj, we're always going to do this, and then we're going to like delete hierarchy. bpy.ops. Oh wait, no. Can we just like Blender Python delete object hierarchy? bpy ops outliner delete hierarchy equals true using the with keyboard. So I don't want to... I wish there was a way to not use the select thing. Yeah, there's some weird stuff with that. Let's just delete object. Because I think what I can do instead is I can just do... So, we're going to do all this. We're actually going to keep this. Else. For C in sister.children recursive pass. And we'll eventually delete the objects. bpy.data.objects.remove. Hmm. So, with... So what is context temp override? Context manager to temporarily override members in the context. Overriding the context to be used temporarily to blah 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 blah. Okay, so what I can do is basically just do this. Selected objects equals sister.children recursive. So yeah, I think this temp override basically means I don't have to like select and unselect stuff. Hopefully. But now what I want is basically add like some meshes in here. So like it's as if we've made a wall already, but I don't like the wall very much. You know, this wall, not very satisfying. Not very aesthetic. Oh wait, these are supposed to be children of this. And so what I'm going to do is I'm going to simply come into our properties, delete the wall pieces, run it again. Almost worked. Cannot access local variable sister where it is not associated with a value. Oh, because we need to do obj.sister. That makes sense. Boom. Perfect. And it didn't change the selection because now they have an API, so you don't have to have like global state every single time you edit anything. Great. It's like they're trying to make the API usable now, but it was designed so badly they have to hack around it by like having these like temporary context overrides rather than just like, you know, like something like this. You know, we're not quite there yet, but we are to like, you know, we can temporarily override the context without like selecting things via the script. But okay. So now that means what I can do is when we go to wall place, sister equals sister. Oh, we should probably have, actually this, we need this up here. Because we're going to be using this quite a lot. In fact, we can just put this like down here. Okay, and here we're going to do p equals bpi.data.objects.new. No, I think what I actually want to do is I want to create a linked duplicate. I think that's going to be in bpi objects or bpi ops duplicate linked. Oh wait, no, we can do this. bpi ops object.duplicate. But I think what I can do is actually one better, where we get the data. So for p in here, we're going to do bpi data objects new, and this is going to be like pillar I equals 0 1. Oh, I plus is plus plus a thing that exists in Python? plus I. And I don't know if it supports adding integers to things, so I'll just do that. So pillar plus I, and then, you know what? This one. And this will get the pillar data. And then p.parent equals sister. And then c.collection. Or bpi.context.collection.objects.link p. And then p.location equals Actually, let's first set, so let's set the inverse, or matrix, inverse parent. I think it's parent inverse, actually. C.active object matrix parent. Is it matrix local, actually? Okay. Actually, to double check that this is actually how it works, move this into here, then move this like this, and then we try this again. Okay. So the parent inverse, as you might have expected, is the inverse of the parent inverse, or parent matrix. And local is what I actually want, I think. I don't understand really, but maybe. Because what I want to do is I want to put it in, now let's just say matrix world. Or like location. Equals, obj.data plus, or no, obj.location plus v.co. Okay. So this should create a bunch of walls as children of the sister, as children of the corn. Not quite. Why was plus equals 1 getting issues before? Return outside of function. Oh, elif this. Okay, now we have these, which they don't have everything that I wanted, but they are in the right location, so that's a really good start. Because now I need to figure out how to, like, duplicate the, yeah, because we got this here. And so what I need is to duplicate... Can I duplicate the pillar, actually? If we just did that. Because, I mean, at the same time... Okay. Pillar 1 doesn't have the pillar property. Oh, I see. Okay, that wasn't a bug, that was just this. Okay, object has no attribute duplicate. Tricky. Oh, because it wasn't... Okay, because it was this. We need to do... Oh, this is gonna suck. Hang on. Just put it back as it was. And then I'm gonna figure out how to make a linked duplicate. With, like how to copy a collection. Let's see, this will activate the active dupe collection in the outliner. This is horrible. This is such a horrible system where you have to have like the correct, you have to iterate over all of the areas on the UI and then like call the operation on the UI itself. This is horrific. To parent 2, consider something like below. Because a collection have many parents, I'm not totally sure, without using the outliner, how to determine which instance of a collection is being duped. bpi.data.collections.new. So context scene, context collision print, collision dot blah, context dot scene dot collection. Copy scene collection into collection? What does this mean exactly? Copy parent collection. Duplicate equals. Default dictionary. None. Then for each collection within the collection, we're duplicating it. bpi object collections new, and we have to have a copy objects as well. So for O in from collision.objects. Okay, so we can do a dot copy there. Could we just do... Can we just actually just do pillar.copy? Like, does that work? Okay, okay, all of that was a waste of time. We could just call copy. And that does exactly what I want. And we can see here, they weren't copied into any other collection. That's nice. I was worried that they'd like also be in here, and that'd be like weird. But okay. All we had to do was call copy instead of duplicate. And now, the next step is to actually start rotating objects such that like they're like correct. Also, I should see if this actually works. Interesting that these... Oh, the constraint isn't applied. Hang on. Delete this hierarchy. If pillar not an object or... Wait, no. Let's say that or sister not in OBJ. Okay, so we're gonna run this again. Boom. Get all this. Oh wait, I just realized I can do this. We can have the wall in it and wall place. Oh wait, no, we need this is what I want. Okay, so remove the wall piece, remove the sister. Get these, delete them. None type is not iterable. Oh, I see, because we're, yeah. There we go. Kind of. I think now I have sister still existing. Okay, so we're gonna clear all of this. And actually, I think it should probably just delete the sister. I don't know. Eventually it's just gonna be a plug and play thing. So it's just not quite working. Oh, and I forgot. The entire reason that I did that was so that I could do this instead. Boom. There we go. Back to where it was, and now it actually like follows the object. And then what I can do is to like really get a hold of how this is going to work. It'll basically be something like this. And then you run this. Oh, didn't quite work. Don't we have sister in here? Why did it create another one? If wall piece is not an object, or sister not an object. So yeah, because we have wall pieces and sister. Okay, so now I think what I can do I have to be not in edit mode? That's the question. No, I don't have, okay, so I don't have to be in object mode. So now the real question, I think, is I need to figure out, first of all, how to rotate these vertices, or how to rotate these points. Well, I guess it's not as important as figuring out the walls. But okay. So we're going to c.activeObject .data.edges. Okay. And so I think what I'd want is for each edge, we figure out its rise and its run. Okay, mesh edge. That makes sense. And this should have... Okay, so this has our indices. And actually, I'm not sure if you meant this, but I do think actually, since you said manually placing pillars, I feel like that'd actually just be a perfectly reasonable workaround for the time being, just because placing these is so much less work than all of the placing stuff in here, that once we actually get that in, I wouldn't mind having to do that every time I like reorganize this thing. Well, I would probably mind it, but now we can like run it again. Didn't create a new thing. It did actually not quite work, though, I'm seeing. Oh wait, no. It's because we're in here. Yes. This is what I need. Oh wait, it's because we need to do this. And that actually means we also need to do, probably mode here. Let's try this. So we run this. Object my wall sister doesn't have the pillar property. Oh, that makes sense. Boom. And then we come into here, we come into edit mode. Run it again. Doesn't work for some reason. Why does it not work now? So it should still be doing the wall place stuff. For this in copy. Oh, because it's not clearing the wall here. Okay, so what we need to do, we don't even need this here. We need this here. And then boom. Deep height objects delete.poll failed. Context is incorrect. So I think if I just did this. Okay. So I can't do it in object mode currently. Oop. Okay. Okay, so I think that's good enough for now for this tool. Or at least for the, like, basics of, like, this. I can accept putting things in object mode. So what I'll do is basically just put in here, actually. To do, let this work, or make this work in edit mode. Okay. Because now, for E in obj.data.edges, so v0 equals E, I think it's going to be C dot index 0, I think. No, not that. Vertices. Okay, we can just do E dot vertices 0, 1. Rise equals v0 dot z or co dot z. Actually, let's just say d equals v0 dot co minus v1 dot co. Slope equals square root of d dot x times, actually, equals d dot z, no, square root d dot x times d dot x plus d dot y times d dot y. And then slope equals, this will be tricky. Not quite. Basically, what I'm going to do is I'm going to get this number, and then the question that I have to figure out, or basically just these two numbers for the size, but then I have to figure out for all of our objects, what are these sizes? So like, where would I have to put these? So like, for most of my objects, the way I design them, like this is the origin point where it would actually intersect with the line, which actually, now that I think about it, would make this a lot more difficult. It makes this so much more difficult, I've just realized. Because I need to consider where the actual origin of the object is. It's like if we had like here. I need to figure out how to place this object such that we can like have these evenly like placed next to each other with this. Well, actually, I don't think that's too bad. Yeah, the main thing is going to be trying to figure out how to get the size of the objects in the collection. Yeah. I think that's what I'll have to do. Slope equals absolute value of rise divided by run. So we have our slope, we have our starting positions, we have the run, and then like for wall in obj wall pieces. Yeah, the thing that's going to be really hard to figure out is how to make this. Oh wait, I just realized also, these actually aren't going to be too bad to edit now that I see this, because what I can do is like I can get this one and then we can like run it. Oh, not quite actually. Oh right, because it's a duplicate. So what we'd have to do is we'd have to delete the sister first, and then we can run it. Ooh, never mind. Okay. So this one works because it's not moved anywhere. This one does not quite work. Life is getting harder for us here on the mines. So I think what I can do is not have... I think I know what it is. It's probably this. It's probably... We can do this. I think it's just doubling up on this. Okay, good. Actually, that makes my life easier. Basically, I'm positioning things locally. I don't have to worry about the global coordinates. I can just get the vertices. And so if we run this again, boom, perfect. As usual. As with everything I've made thus far. Okay, so like get, so like size equals get wall size wall. So let's do this first. It'll be like right, this will be size dot rise divided by size dot run. If wall slope is less than or is greater than, no, I think it is less than. No, like let's do like good wall pieces equals nothing. Alright, let's say get size. Alright, now, this should be vector. Now, what should this be? This will be a collection of something. Let's return... Let's see, can we print an error in a, like, good way instead of, like, the nasty way that I'm doing it so far? Python, Blender, print. Hmm. Okay, so the only way to actually do this is to just have the console out. We'll just have the console. Because what I'm going to do here is if good wall pieces, let's say if not len, print no wall pieces for edge plus string ed or e dot index term. And for now, this will actually be impossible to use, but that's fine. Boom. Oh, int object has no attribute co. Oh, it's because it's probably verted. Okay, I see. So this is obj.data. Like that. I love meshes. I love index buffers. Okay. Name square root is not defined. From math, import square root. Object is not iterable. So that is 75? What was that? So 9190 or 9175 for wall and obj wall pieces. No, it's an array. Oh, wait, hang on. We need to delete hierarchy. There we go. Yeah. So let's do C active object dot wall pieces. Data.objects stone wall simple long. So it's only one object, even though that's not how it's, even though that's just not how it's supposed to work. Hang on. Run this again. Oh, wait, hang on. Am I? Oh, whoops. Okay, well, that was easy. Wait, whoops. We gotta clear this. Name rise is not defined. Well, that's better. Actually, why don't I just get the slope here? Hang on, we're just going to do return 0 here. We're going to do like get slope. And eventually that'll be like better. Okay, let's see what this does now. No wall pieces for edge, 0. Oh wait, now what we need to do, continue instead. Okay, so now we see the very basics. And then what we need is to basically actually get the size of the walls. So let's actually commit this. Placing pillars. Or like, let's say, wall tool. Placing pillars. There we go. Oh, I just realized, if I place the pillars at these boundaries, then I can't make the walls not merge together. Or basically, then there's no way to make it so that, like... Well, that's not enough to deal with right now. Edge this. Hang on, let's do an F string. With slope. Let's make sure that these are actually, like, looking correct. Okay. These are about right. None of them are over 1 because none of them are at more than 45 degrees. Or none of them are at more than, like, what would it actually be if we did this? Ooh, actually, what happens if we divide by 0? I just won't divide by 0. I don't care. Okay. Else. Or then 4G in good wall pieces. So we're gonna have like our slope be equal to oh, we do actually need the size of the object. You know, I'll just get the size again. Let's do like size equals of, or like get wall size G. And like covered distance equals 0. And so we'll have like basically like so like var o no w equals good wall, or like g dot copy. This is gonna be tricky actually. I guess it won't be that bad. Basically, for each piece, we'll just get them in a random order for now. Eventually, we need to sort these by length, or from longest to shortest. Cover distance equals 0, so we're gonna get like the wall size here. Then, the position we place the wall is going to be covered distance plus size dot x divided by 2. Basically, we assume the wall is symmetrical on all sides. Yeah, I'm not exactly sure how I'm going to calculate the slope of these objects. Well, I guess it would be just this size divided by this size. Actually, that'd be pretty easy to figure out, but yeah. And then it'll figure out, like, basically... See, actually, how much do I want? I think a lot of these will not be covered by the wall, but oh well. Yeah, so we basically, like, have this start at, like, 0. So I guess right here. And then we position it wherever it should be with the origin there. Actually, that's going to be really hard to figure out as well, because we want this here to be... I'll just position them horizontally first, then figure out how to position them vertically. Yeah, for now it'll basically be like this. And in fact, we won't even have them rotated right now. We'll just position them such that their centers will make a theoretical thing here. Yeah, the hard part's going to be figuring out the length and the width of the objects. Well, length divided by height, or height divided by length. Because yeah, it's actually going to be just get size here. Actually, what's the vector 3 that we had here? So if we go back to edges or vertices, oh, I see. We don't have one active object. We have multiple active objects. Okay, it's just called a vector. I'm going to do a return vector 0, 0, 0. Let's see if this works. Because basically this is going to be our size equals get size wall. And we'll just get the size twice because I don't care that much. Okay. And then wall slope is actually just going to be size.x divided by... Oh wait, no, size.z divided by size.x. And if the wall can go above the slope... No, I think it actually should be 0.5. Basically, if it can go, like, from here to here, and this covers less than half of it, actually, it should probably be, like, 6 or 7.5 or 6.5 or something like that. It'll do something eventually. It'll work eventually. But then we append a good wall piece. And so yeah, I think what I gotta do is I gotta iterate through all of the children of this object. And that'll be like, let's do like min equals vector. Or like AABB min equals 0, AABB max equals vector 0, 0. Return AABB max minus AABB min. None type is not iterable. Oh, because we're not iterating a thing. Vector is not defined because it's somewhere else. Where would it be? bpi dot mathutils? Oh, is it just called mathutils? If we just did from import mathutils vector, more than a single arg given. How do we construct a vector? Oh, as a tuple. Interesting. Okay. Kind of annoying. Kind of not very useful, but I guess it's just to automatically convert from a tuple to a thing. Okay. So now, float division by 0. Whatever. I'm gonna use the bathroom. I'll be back in a second. Alright, I'm back. Okay. So the current conundrum that we're on is actually just making the logic for the size. So I think it's going to be get vertices. Oh no, data dot vert, or let's say like if wall object dot data and wall oj dot data dot vertices for v in data dot if we're gonna have these L H because we need it. We're gonna do a lot of vertices comparisons, like H dot X less than V dot X, H dot X equals V dot X. If I just realized what I can probably do is H equals. Actually, do we even need these tuples here? We probably do. Do we have like a max and min here? Not quite. Oh well, that'll be fine. Wait, actually, do we have like the ability to quickly access the quaternion or the tuple? Components of an existing color can use a slice notation to get a tuple. Decompose. Tuple of translation, rotation, and scale. Okay. 2 axis angle, 2 swing twist, 2 tuple. I think I'd prefer these, actually. No, I'm going crazy. I don't know what I want. Because basically what I'm going to need is max h.x v.x. Max, hi, welcome back. h.y v.y. It's going okay. I'm trying to figure out how to get the size of a collection of objects in Blender. So I need, for example, this data. So what do we have here? Oh, active object. Okay, so we got no data. That's good to know. But do we have children? Ooh, this is actually gonna be harder than I thought. Because these are all these are like these collections. So I don't know how to get the children of it. Because we have an empty collection here. Oh, I bet you it's objects. What if we did active object dot, No, we don't have that. Yeah, because the parent of this... What would the parent of this be? Okay, so that's as I expected. That's just this thing. But yeah, I need to figure out how to get access to all these juicy meshes, because what I need to do is iterate over all of the vertices of this. Unless there's some other way to get the size. Actually, let's double check that first. Like Blender, get size of selection. Oh, edge lengths. Well, I have the active object. It just doesn't have any, but it's not a mesh, it's a collection. So it has no data. I need to get the objects within the collection. But unfortunately, I thought I could do that with children, but children is also empty. And so it could be users collection. Oh, I see. Interesting. Okay, that's a useful way to get that. So check object and see something. Yeah, because we have quite a few possible places to look. Maybe original. I mean, we have the C active object. We have the active object right here. This is the active object. What I'm trying to do is figure out what the objects within the object, because this is a collection. But I want to figure out the size of the things within the collection. Oh, is it just dimensions? Oh no. That was close though. Okay, but it is good to know that this actually does work if we have dimensions. Actually, I'm gonna see, can I convert this to a Boolean? Okay, no. I'm well aware that this returns the data. The problem is, it doesn't have the vertices because this object is not a mesh. It's a collection. And inside of it, somewhere, somehow, is the meshes. And the question is, where are they hiding within the data? There is no dot mesh. It's dot data. But dot data doesn't have anything. Hang on, I'm going to try to figure out Blender iterate children or iterate objects within collection object. Dot objects, dot children recursive. I guess I could try children recursive. Yeah, because it would do this. Oh, wait, what? Huh? Does it just not print things? What the heck's happening? I should have known. Oh no, it didn't print anything. Okay, never mind. Wait, what? Now it's not printing. Oh, wait. That's because it doesn't have any children. Okay. Okay. So this object has children. But this one does not have children. And that makes me sad, because that means that it does something different to have this collection in here. What exactly is this? How do I figure out what this object is? Is there like a type? Empty. Okay. Is there more? Is there anything else that I can get here? Up axis, update tag. Use dynamic. So using probably isn't going to be right. Value, shape, session, scale. Original. What if we... This is a thing. No, okay. The original is the same as the object. Is it a library indirect? Instance collection. Is that what we need? Okay, and then we do objects. Ah, okay. I have now figured out how this works. Okay, so we get the active object instance collection, or instance collection dot objects here. Then we can get that. But first off, or let's say if children. So how would we do this? I'll figure that out soon. Max or min, actually here. And actually what I'm going to do is low and high equals like match, or like contain v. There we go. Beautiful. So let's say like if wall obj.instance collection. We'll do this. So it'll be, I think it'll just be like LH. And so like to do objects at different positions. Because right now what it's just going to do is LH equals contain, I think this should be get size C. There we go. And this should get us some more sizes. Okay. So this might kind of work. Oh, right. Because this doesn't have a pillar property. Almost. Mesh vertex attribute has no object blah. And that's because we need to go through the vertices and we need to do .co. Oh, wait. Ooh, no, this is not quite correct. Yeah, you know what? Let's do get bounds. And then we'll just return low high. Oh wait, no. That's not the right place. That's the right place. Def B contain B. And this will be ooh. I know. There we go. Okay. Def get size wall low high equals get bounds wall return high minus low. There we go. Phew, easy. Not quite. Cannot unpack non-iterable none-type object. So that was in 82. B contains get bounds. So for C, in wall object instance collection. Let's try that. Cannot unpack non-iterable none-type object. So I don't quite know. Let's try this. So that should have printed something. Collection, collection. And then if we do dot objects, that should do that. And then we see here, we have collection objects. And, So why can I not get these? Because if we do this again, so for O in active object instance collection objects, we get that. So does that mean there's something else that's wrong? Or like we're getting some other object that doesn't have these? Maybe it's like if we get this here, or C in get children, or active object, no, not quite this. For O in C dot instance collection dot objects, okay, so that works just fine. So it's specifically the wall objects seem to be wrong. So why does this not work? Is it even this line? Is this the correct... Maybe it's this thing within here. So does B contain... I guess that should be fine. Oh, maybe it's because we don't do this. So, like, we need to return this, basically. Well, actually, do we need to do this? I don't understand what I need to do. So it might have been, it might be that. I don't think that's actually correct, though. Oh, right. Those are some random notes that I've been having, because I've been listening to noise music recently. So yeah, I want some spooky music. But okay, so if run equals 0, let's do slope equals 0. If run not equal to 0, yeah, because I want it to feel spooky. Else slope equals infinity. How do we do infinity in here? Row division float by a 0. Let's just say... Oh wait, no. This is wrong. Now what it should be is... if rise equals 0... No, what am I trying to do? If run equals 0. Gamer. No. Print. Nah. Or like skipping edge e.index. Or no, continue. And then here what we need is if size.x equals 0. And for now, just actually print invalid wall dot name. Okay. Where are we doing that? 121. Size.z divided by size.x. If size.x less than or equal to 0.0001 or something. Let's try that. That doesn't feel possible. How are we getting a division by 0 when I explicit... Oh, wait. I see. Because I don't continue. Okay. So now, we're getting wrong stuff. And actually what we should do is the min and max should be different. Wait, no. This doesn't make any sense. This makes sense, though. So the low and the high should be like that, I think. Okay, now we're getting actual sizes. This is great now. Now it's all cool. So we have now calculated the size of these objects, kind of. Yeah, okay, yeah. We got the post. It's 5 meters tall by this wide. The wall short, wall long. Okay, good. This is good. Now what I need to do is I need to change this to the other object. Because it needs to be a simple medium wall. Yeah, we can celebrate now. Okay. Calculate wall size. Okay, so now the real challenge begins. Exactly. So we have our good wall pieces here. Oh yeah, now we don't need to print stuff as much. Yeah, because I was confused because this was actually... because this was not returning a thing. Okay, so while... What do I want to do? I want to sort these walls first. How do we sort in Python? Actually, is there... let's look through arrays. Mapping types, Boolean types, maybe iterator types, other built-in types. Let's see, so I'm going to collect a data instance between objects and put walls. Basically what I want is, I want to be able to draw a line, and then it automatically calculates how many wall pieces it needs to put, such that the walls, like, sit here, and then go up to, like, here, and then it puts the next one, like, right at the appropriate location. And so right now, all I have is the pillars being placed. But now we have the slope of the edge, the size of each individual wall, and we can eliminate certain wall pieces. And so now what I want to do is I want to sort them from smallest or largest to smallest. And I don't know how to sort. Byte array, memory view, given an array of bytes. Many other operations produce lists, such as the sorted. Yeah, eventually, the long story short, this will eventually turn into cool walls. And it'll place little wall prefabs all along these lines. And they will be perfect. And then I'll finally have good code, and I'll finally know how to script in Python. Yeah, how do I sort a list in Blender, or Python, though? The sort algorithm uses only less than comparisons between items. PEP 8 recommends that all 6 rich comparisons be operated, or implemented. So, I don't think that's going to help us very much. List.sort is probably what we need then. This method sorts a list in place, using only less than... That's not quite what I need then. Comp to key utility is available to convert 2x style comp function to key function. I don't know if that's going to do anything for us. Okay. I don't know. Oh. I don't think I've ever actually used DeepSeek. Python sort array with function. Actually, I just realized, so what I can do for good wall pieces is we can append a tuple of wall and the size, so that way we don't need it here. So what we can do is for G size in good wall pieces, Oh, okay. So sorted actually does do this. That's confusing. I thought it didn't. Oh, wait, no. Wait. Huh? Oh, this is just... I'm confused. Because it says sorted only... Hang on. Why did I think sorted only returned a function? Key none, reverse equals false. The built-in sorted function... I'm confused, but it seems like what we actually do is we do sorted if n equals blah blah blah. It's just going to be sorted good wall pieces lambda a b. What? Wait, how does the lambda function work? Comp equals. And then we basically do like how do we get the... Hang on, Python tuple. Can we just get the 0 object from a tuple? I'm gonna assume I can do this. So like A0 less than B0. Oh wait, no, this should be 1. We're gonna get the second object. And then what I'm gonna do is for G in... Actually, we're just gonna print. G.name. Size. Okay. That makes sense. Okay. Comp is an invalid keyword argument for sort. Oh, because it's... Wait, huh? Oh no. Good wall pieces. So comp is not a keyword here. Am I missing something? How custom comparator works. Return 0 when both are equal or whatever. Okay, so eventually I'll have to do something like that. Oh wait, because we need size.x actually. I literally have no idea what you're trying to tell me other than to not use the thing that I'm using that I have. Like, I don't know what you mean by use value or whatever you're talking about. Like, you have to understand that the only time I ever use Python is when I'm scripting in Blender. So when I see, like, this is how you sort in Python, is it key then? Do I have to use func tools? Do I have to do this stuff? I don't understand any of this. Like, I have no idea what value means. So sort accepts two functions. So what are the functions? I think you meant the word... Okay. Missing one required positional argument B. Is it this then? Do I have to do... Hang on, what? Wall place locales lambda. Missing one required positional argument B. Oh, I see what you mean. So key does this. It doesn't get the... So you sort by a particular key. You don't take a function that compares the things. Which for some reason doesn't work in this particular implementation for God knows why. But that does mean that now we can sort by the things. But also I do need to remove the wall pieces. And the sister item. Well, actually, we should not have removed that. Oh well. Okay, so now we have sorted the objects from smallest to biggest, which is not quite what I want. So what I'll just do is just flip it. Just go negative. Because we want the largest objects first. And that way I can be lazy about it. So sort objects from large to small. But alright, thank you for the explanation. But okay, so now what we can do is we go through this, and while the size, or like let's do if, while covered distance less than run. So we're gonna do I think it would be V0. So like position, we want a position that is this vertex plus the oh wait, and also we need w dot equals sister, w dot, I think it'd be, whenever I do this collection, I can actually do user collection, or users collection. Zero there. So just get the first collection that it's in, and then link it. And we can do that the same for here. And I think this will be g.location equals w0. We need the difference between these two. Normalize equals d.normalized. Oh, wait, no. N. I hope this works. Actually, we can just check this. Vector. 1, 2, 3. And then we can try to normalize it. Okay, good. And actually we need .x, d.y, 0. For now I'm going to get only the horizontal component. So this is going to be v0 plus n times covered distance plus offset. Or no. Actually, yes. Because offset is the size divided by... Oh, wait, no. Okay. We already covered that. And then cover distance. Size.x. And actually, we need this all in here to be in here. Okay, so while cover distance less than run. And, I guess... No, I guess this is fine. Less than run plus size.x. Divided by 2. I guess, that. Okay, so this will be kind of confusing, but basically what this should do is it should place some walls. If I played my cards right, not quite. Mesh vertex plus vector. Oh, because the... Right, because this actually needs to be co, eventually. Right there. Object stone wall already in collection. Oh. Then we don't need that. Oh wait, we need this. So this thing's location equals that. Almost. We're getting close, you can see. So I think now... Oh. So whom is for where? I think what I need is w.name equals g.name plus okay, so these should have unique names. I think there's a lot of these. Oh wait, no, I see. Okay, this seems all correct. The real question is, I think these are all, like, not going the correct way. And I wonder... So the x-axis should be pretty big. If we go to these long walls, 8 meters. Okay, so the x-axis should be this one. And so that should get us, while covered distance plus size less than 2 less than run, or size x divided by 2, offset equals this, covered distance plus equals size dot x. Yeah, it should be spawning a couple walls, because basically the goal is, like, for this place, for example, it should probably spawn, like, 2 walls, because basically right now what it'd do is this, in essence. So it should try placing walls like this, and then it'll eventually, like, I'll have some, like, better algorithm for it. Because there's a couple bugs that I see. One is, it always defaults to these long walls, even though they have the wrong distance. And the other is that, well, it's placing them in the wrong position, of course. And the other is that... So what is run here? Square root dx times dx plus dy times dy. So that should be correct. The slope equals rise over run if 0.65 times wall slope greater than slope. So they should be... Oh, and it does this for each edge. That makes sense. Yeah. Because I think it's calculating the distances wrong, but what I can also do is we should take, so this times offset. So where are we going from? Oh, I see. First thing I should do, just to simplify this, do this, so that way, when we run this, it'll be going the right direction. Oh, wrong thing. This one. Okay, so now they're going the right way. Okay, so I think it's just something is wrong with my multiplication. I forgot how to multiply. Yeah, because you can see they line up halfway, not the whole way. So wherever I'm doing the size, so this equals covered distance plus size x divided by 2. Yeah, now it's the math that's wrong. And then the W location equals our first vertex times normal times offset. Covered distance equals size.x. That makes sense. Users collection objects link. So where would this be going wrong? Like, it wouldn't be here, because this is just going to move it so that they start here instead of here. I think it's the sizes are the wrong ones. Very strange. Like, I think it's actually, like, this size is not associated with the right thing, somehow. Where else do we print? I'm not going to print here. Invalid wall, no wall pieces, print G, f.name size. Let's do this. And then we're also going to print up here, like e.index. I could actually check the max of size.x, size.y. That'd be good. Oh, wait, whoops. Keep getting the wrong thing. Yeah, let's put size as s equals max size.x, size.y. And that way here, we do this instead. Though it'd be way more messed up with Oh, I see. I think I understand. I think it's starting from here and going down this way. Actually, I know what I need. Placed equals 0. So dash wall placed plus equals 1. So that way I can see exactly what's happening here. Oh, right, I keep doing that. Okay. So we started from here, and also let's hide these because we don't even need to see these anymore. And we don't need like random stuff that's like not children of things. Why is this not like in this collection? Can I like remove it from the collection? Because wait, I'll just hide it. Who cares? What is this one? That makes sense. Okay, that's fine. Okay, so for this one, we see it kind of working. So this is wall 0. So this is the first object that's being placed. which feels like it is in the correct place. So it's strange, which is really weird to me, because it doesn't make any sense. Oh, it does make sense, actually. I think. No, it doesn't. Wait. Doesn't make sense at all. Oh, because... Okay. No, I'm going insane. Hang on, let's print the bounds here. I think it's something to do with how I actually calculate the bounds, where the size is not actually correct. It's like half the size it's supposed to be. Okay. Well, I don't get it. Wait, huh? Hang on. Okay, bounds of this. 0 to that. Okay. That is the issue. So where does it all go wrong? LH equals contain L2. LH equals contain H2. Return LH. We don't even really need that, but that's okay. So we can print, Oh. Wall is not defined because this is wall OBJ. And if this fails, I'll just multiply it by 2, but I want to get the size correct-ish. So let's see, like, where do we get where does it all go wrong? So when we get the bounds of an individual object, it's correct. But then when we combine the bounds together, we get 0. And that is not cool. And so that means that B contain is probably wrong. So with L2, with H2. I have to go through all of the vertices, but I have to also go through all of the children of all of the objects recursively. L is not associated with a value. Ooh. Oh, I see. Wait, no, I don't see. What? So at line 57, this should have, I was hoping these would be like self-contained or like non-local references. Hang on. Does Python support non-local references or whatever it's called? Nested functions, variables from outer function. So now, because now I don't know if I'm declaring new variables, and it's like, that's why it's going wrong? Because what I can do instead is just have like S equals like this as like L H equals S. And then we just do L of H here as well. So like S equals this, L H equals S. And then everywhere we do this, we just do H. This is why I prefer languages where you have to explicitly declare variables. Contains missing required argument. For whom is this? Oh, I see. Okay. Now it makes a bit more sense. And now we have to bring this bad boy back, which is cover distance divided by 2. Oh yeah, I keep forgetting. And soon I'll even rotate them properly. But now the vision is coming together. The next thing to do will be the actually hard part, which is getting these vertices to like, or getting these walls to actually line up with these pillars. Yeah. So it'll be rotating these things, and positioning them vertically will actually not be too bad, because I think what I can do is, instead of, like, I can just not use this here and just do this. And I think, so I'm going to remove this. I'm just going to do size.x. Because if I do make walls where y is the long one, I'll just, like, kick myself for not making it compatible with this. But okay, now we're getting a little closer. And I'm thinking I'm going to put a margin on these. Well, eventually. I'll see how I feel about it. Now, the normalization is because I get this distance, but then I'm actually placing it based on the size of this object, so I just need the direction. But yeah, now the issue is the fact that, like, it doesn't know to switch to, for example, the lower mesh here, because it only does that when it's greater than half of the distance. Which actually, I think what it needs to do is it should be like plus S here. Though this will mean that basically they just don't, like, get all the way to the end. Because now what they'll do is they're always going to be short. But if we did plus shortest divided by 2, so shortest is going to be equals good wall pieces. How do I do this? -1 divided by 2? Or dot? This will be complicated, but it's going to be 0.x divided by 2. Oh, actually what I want here is, not quite this. S divided by 2 minus... I think it's S minus shortest divided by 2. Yeah. Oh, not quite. Object has no attribute X, and that's because this is supposed to be 1. Okay, there we are. Not quite, actually. And I think it's because this here... Shortest divided by 2, less than run. Oh, but we already do... Okay, I see, hang on. Actually, we should do that there. Basically what I want is... if the covered distance will be less than half of the smallest object, we will keep using this one. Otherwise, we go to the next smallest one. Alright, I keep forgetting to do that. There we go, okay. And now you can see it goes to these two, and then it switches to the shorter node here. And so it's not exactly magic. And you see here it doesn't even bother, because there's so little space that it's like, ah, whatever. It'll figure it out anyway. But okay, now the next step. Rotate the thing, such that it, like, its axis aligns with, so we need, d0 equals, vector 2, or no, vector d dot x, d dot y, 0. Dot normalized. This will be like NH. So this is the direction we want the x-axis to align to, and that would be by, how do we get rotation? I guess we could do, let's get this thing. Oh. C dot active object rotation. Oh. What does it have? Oh, rotation, Euler maybe? Yeah, it's gonna be... Yeah, I've been programming for about 10 years. So I guess it's just... I think it's just I've been not using AI for so long that, like I've used ChatGPT actually for a little bit of stuff, but today I tried to make a point of, like, not using it. I wanted to learn how to, like, understand Blender's, like, documentation, like this stuff. Let's see, so can we do, like, a dot angle? So we can't do that. Any... I bet it's in Math-Utils. Yeah, basis would be good. Let's look at Blender Python basis. Matrix basis, okay. So if we did c.activeObject.matrix basis equals... Actually, what do we have here? Oh. Has no attribute matrix basis. Oh, do we not? Oh, wait, no, hang on. Did I just type it? Okay, I just typed it wrong. Okay. And so then we can do, hopefully, like a pointing at. Diagonal copy, decompose, determinant, identity, invert. Orthogonal, valid. Rotate. Rotates a matrix by another Math-Utils thing. So we can do Euler. Okay. Yeah, not quite, because we need to get, or because this object is basically just a mesh. Because we need specifically this line here, horizontally. And so I think it'd be like angle. Okay, I think actually we'll need this. This will be like w.matrixrotation.rotate, yeah, vector. I think it's going to be 1, 0, 0. Angle to it or something. Yeah, let's look up vector. Oh. So do we have anything? Yeah, I don't think there's... Is there an up? I don't think there's vector up here. There might be. Nah. They don't got it. You gotta hard code it. So angle. Return the angle between two vectors. Okay, this seems promising. So I think what we can do is rotate dot angle NH let's do like 0 0.5, 0 0.50. So this should be like 45 degrees, 78 readings, whatever it is. But we gotta turn this now into an Euler. Angles. So I think we only need the z-axis, so we'll just do like 0, 0. Okay, let's see if this works. Doesn't seem like it quite did. Oh, because Euler is not defined. Where is this defined? Oh, is it because I did, yeah. Let's just import Math-Utils. Not quite. From math utils, import vector Euler. Alright, because I forgot that there's the namespace by default. Euler takes at most 2 arguments, 3 given. Is it a vector, actually? Am I missing that? Oh. So, can this be... Okay, I see how it is. We do more parentheses here. That's what we needed. Boom. Matrix rotate must have 3 by 3 dimensions. Oh. Rotate other. So type Euler or class. So it can be of Euler, quaternion, or matrix. Rotates the matrix by another math utils value. So why is this not right? Matrix rotate must have 3 by 3 dimensions. Maybe we just do matrix local. There are paths in Blender, but I'm not using paths because I specifically wanted the ability to make right angles pretty easily. Well, admittedly, would anything... I'm actually not sure what would be simpler here. I guess it probably would be... I don't know. But okay, so that's not the right thing. Matrix basis, so let's try... Actually, I just realized. We can just set this here. I thought we could. Yeah, so what is this? So, tangent cross. Yeah, that's doing stuff with paths and stuff. I don't have anything with paths right now. Oh, I keep forgetting. Okay, it's just rotation Euler. Almost. We can see in some places it is working, but in other places it's going the opposite direction. I think I can fix that by getting the sign of the cross of nh.cross. We just need this, so this is going to be x. X equals vector that. And then angle equals angle that. And then, so this will actually be sine x dot cross n dot h. And this will either be positive or negative. And then we just do angle here. In fact, we can just have this here. And then this is angle. So that should now... Alright. Not quite. Sign is not defined because we need to get that from here. Boom. Oh. Get the sign of an object. Oh wait, no. I keep conflating Blender and Python now. Why doesn't Blender have a sign function? But it wasn't accepted because they didn't agree what it should return at the edge cases, so they decided to only implement copy sign. Alright, let's do that. They gotta be a special little guy here. Must be a real number, not vector. What did I do? Oh, I see. This should be Z. Because it'll only have a positive or negative Z-axis. Alright. And so now, the reason that this edge is skipped should be... Oh wait, let's remove all of our prints. We got so many prints here. Yeah, we got 1 billion trillion prints. Okay, so skipping edge as it's too steep. Oh wait, no. As it has no... Let's say skipping 0 length edge. Okay, and let's remove this. Run that again, and now the console should tell us no wall pieces for edge 0 with slope blah, as it's too steep. Is too steep. Okay, so there's still some more work to do because now I want to be able to place, for example, I want things like this aligned with the tallest wall. Or like the first wall and stuff like that. So definitely more work to be done. And then also I want to place these along these like this. So what I guess I could do is probably just place the place our thing here. So hang on. Where do we place this? So we get the pillar here. We're not going to do that anymore. We're just going to do this, delete that. We don't really need this anymore. So now we'll just do like pillar equals copy, p.name equals c.name. What am I looking for? Let's just call it pillar 0. And then p location equals v0.collision, and p.rotation Euler equals angle. And so this way, we'll have these start and end with the other objects, which won't be quite right. Oh wait, yeah. And then we should also have it do like first size here. So like equals, actually, how do we do this? Because this should have the same z-axis. Oh, I see. If not aligned, what we're going to do is basically just p dot location dot y or z equals w dot location dot z aligned equals true, and up here aligned equals false. Oh, not quite. Oh, I don't think not, or I don't think the exclamation points exist. Oh. For a language that eschews, well, constant values, I guess, are capitalized in Python. Okay. Now it does more or less exactly what I want, at least at the start of the things. Now the real challenge will be making the end boundaries behave nicely. Thank you. Oh, there's some boundary conditions that need to be worked on. But it is 10:30 p.m. here, so I've been streaming for, well, I've only been streaming for 4 hours, my normal amount. But yeah, so the next steps will be the interboundary pillars, pushing and pulling things to make them, like, match up. Because, like, for example, I'd like the ability to, like, really get fancy, like, you know, you could put things here, and then it, like, looks all matched up and aligned properly. Even with the walls, like, slightly the wrong length. Well, if I did it correctly, you know what it'd look like. It'd look all good. It'd look all nice. There's some sophisticated stuff left. But, at the very least, I now have a cool wall algorithm. The start. Well, as we've seen, a lot of trial and error. And so now, if I go to... What was this even under? Whatever. I'll just put under features, wall placer, so like pillar boundary conditions, and then alignment with inter segment pillars. There we go. And I guess those are really the only two things left. Just basically figure out how to make it so it always picks the tallest pillar, basically. Oh yeah, and then also final pillar. Because basically, this is missing a pillar. Which I guess is part of the boundary conditions as well, but... Yeah, and then the last little piece would be getting it's interesting that these are actually, like, they already have a slight overlap. Huh. Yeah, basically squishing these together when they need to be squished together and pulling them slightly apart and then putting a pillar in here when when they need to be slightly further apart. But alright, that'll be it for today. I'm quite happy with this, because now I have a power of somewhat understanding how to Google for Blender Python scripting stuff. And I think that makes me extremely powerful. But alright, I will be back Friday to hopefully finish this off. See you then.